started just to talk a little bit about some of the other activities that are happening later this year. Of course, we're here tonight. October section meeting is going to be, let's see where we're going to be in El Segundo at the Automobile Driving Museum talking about Faraday Future. So it'll be kind of interesting. I already had an opportunity to go there myself, so it should be kind of fun. And for November, we are going to be in Torrance at Honda to talk about 60 years of their American work as well. So we're very excited about that. Of course, we're always planning new events, and right now we're starting to look into the early 2020 timeframe. And I guess the last thing that I'll say before I introduce our SEMA folks is I'm very excited to say that Formula SAE is coming back to Southern California. So for anyone that has been involved in Formula SAE as a student, as a volunteer, I think it's been, last year was like 2011 that I think I was involved. It's back. I believe, Dean, correct me if I'm wrong, I think it's at Cal Speedway again, right?
Auto Club Speedway.
Auto Club Speedway. So that is timing to be confirmed, but around May, June of 2020. So we're very excited about that, and we'll need a lot of people to help. So if you're interested in helping out, we're happy to talk to you about that either tonight or in the future. So again, good things coming back to Southern California. With that, I'll make it short and sweet, and I'll introduce Mike Spagnola, who is the VP of OEM and Product Development at SEMA, and he'll kick us off.
Thank you all for coming here tonight. A couple housekeeping things before we get started. Most of you probably came up the stairs here, but we've got stairs on this side. If anything, if there was any sort of emergency, stairs on this side, stairs on this side as well. We have a set of bathrooms here upstairs and another set of bathrooms downstairs. And just in case of any sort of emergency exits, wanted to let you know how to get out of here, right? Well, welcome again. I'd like to introduce, if you wouldn't mind, some of our SEMA staff. Chris Kirstein is our president and CEO.
Hey, everybody.
So we're really excited to have Chris here. Chris has been on our president CEO going on 20 years. Is that right? So has really led SEMA from its early beginnings to just an amazing association now. And so we're lucky to have Chris as our president. We've got Zane is here from our education team. So Zane oversees all the education team, all the scholarship program. Several SAE students certainly apply every year for scholarships, and so Zane oversees that. I think 120 or 130 education seminars during the SEMA show and education out throughout the year. So Connor, Gary, and Luis are here with us. They're part of our engineering team. And we'll get into what they do in a minute here, but they do some really amazing work. All three of those guys, I think, are Cal Poly Pomona, am I right?
Yep.
Cal Poly Pomona, all SAE, next student, Formula SAE?
Yep.
Is that right?
Yep.
I got it right. Okay, so just amazing young talent that we have here at SEMA, and certainly their SAE background and Formula SAE background has been a real asset for us. John Waraniak is here. John is going to speak a little later, but John oversees our vehicle technology side as part of the SEMA Garage. I don't think Gina is here. Gina was downstairs. Who did I miss from the SEMA staff? Anybody? Did I get us all? Great. We got some other dignitaries here tonight. Gail Banks is here tonight, and Gail is a American. I guess I don't know if we'd be embarrassed if I tell you this, but when I graduated from high school, Gail was at the Automotive banquet and spoke at our Automotive banquet. That was in 1973. But he has been involved in high school and college and development of students for going on 50 years, I believe. So pretty excited to have Gail here tonight. And then who do we have some SEMA, who is here that is a SEMA member? I know Lana Christmas here. We've got several of you guys here. So thank you for being here. Let me tell you a little bit about the garage. The garage is SEMA Garage is a product development center. And what, we developed this program about 6 years ago. I think, Gail, you were on the board back then when we voted to do this, but the product development center is to help our manufacturers develop products that get on the marketplace. And so we work with about 3,000 SEMA manufacturers. We help them with everything from CAD data. So we have the OE CAD data for Ford, General Motors, FCA, and thousands and thousands of files. So as a SEMA manufacturer, you can have access to those files. So let's say, for example, you wanted to develop high performance suspension on the new Mustang or a lift kit on the new Chevy Silverado. We would hand you that OE CAD data, and then you could do your development work to modify and to get your new products. And so we do that for, again, 3,000 different SEMA manufacturers or have access to that sort of data. So if you're developing superchargers or air intakes or any of those sorts of things, I know Gail's company takes advantage of those files, I think, just about weekly. And so if we don't have that data, we have a ferro arm. Some of you may have seen that demo downstairs, but we can actually scan and reverse engineer just about anything now. So the days of having to do all those measurements with micrometers and all those sorts of things now, it's I've actually had builders and people tell us we're cheating now because we can scan and reverse engineer that quickly. So we help manufacturers with that. Once they've developed the product, we have that CAD data. Once they've developed the product, we can 3D print it for them. So we can 3D print suspension pieces. I think our printer prints 9 different materials. We also have a second printer now that'll print off rubber boots and those sorts of things. So you developed your product, send it back to us. We can 3D print it for you, get it installed on the vehicle. You can do all your test fits prior to going to manufacturing. So we literally have taken some development time. On an air intake system, we did some measuring, and we took an air intake from 6 months down to 6 weeks, from start to finish to get that product developed. And what's that mean? It means that manufacturers can get products to market in a much quicker, much highly engineered manner, and make sales that much sooner, right? One of the other things we do here at the garage is we do these things called measuring sessions. So somebody had mentioned a couple weeks ago we had some Aston Martins here. We work with the OEs. That Toyota Supra, I saw one in the back. That Toyota Supra was here in April. So we work with Toyota, get that Supra here. We invite members in, manufacturers in. They can do these measuring sessions. We'll blow these cars apart. We'll take air intakes off. We'll take turbochargers off. We'll take these cars apart and help them with measurements on those sorts of vehicles. And then they can actually do prototypes and even come back and bolt those things up. And so again, it's helping in decreasing that time of product development, right? And any of you that have been in business know that to grow your business, you need 2 things. You need more people to sell to, and you need more things to sell. So the SEMA show helps you with more people to sell to, and we think the SEMA Garage helps you with more things to sell. So these are the things we do the other 360 days a year. I know we're known for our SEMA show, but the product development cycle is really important here. Lastly, you would have seen the emissions lab. If you develop a product that affects fuel or air, and we have about 500 manufacturers that develop products that affect fuel or air. And if you develop one of those products, it's got to go through a CARB EO certification or acknowledgement before you can sell that product on the marketplace. Peter Tribe, who was here earlier, who, by the way, worked for Dell Banks for 20 years. Peter runs that side of our business. He helps the manufacturers actually fill out the paperwork and get it through the system with Air Resources Board and EPA. We'll do that testing for you. We'll get you the paperwork and the testing needed to get that CARB certification, that CARB EO, and get you through the door. The fine now, if you decide to develop call it supercharger, air intake, any of those sorts of things, if you want to develop those things and start selling them without that CARB EO, the fine can be as much as $37,500 per part, per use. So you can see where that's a great asset for our manufacturers. That lab is actually next month moving to 2 shifts, and we're looking for other expansion there as well. So those are some of the things we do here in the garage to help our manufacturers, again, get products to market in a very highly engineered way that gets them to market sooner, so that when that new vehicle hits the marketplace, products are ready to sell. We know that those product sales happen in the first 18 months of most of those sales happen in the first 18 months of that vehicle coming to market. SEMA is we're a $46 billion industry, so pretty large. We have a large, how many of you guys have been to the SEMA show? Yeah, several of you. So you know it is a pretty large event. I think 170,000 people show up at that show every year, about 2,500 booths, 2,500 different manufacturers, and it's coming up here in a short 4 or 5 weeks, so we're all thrashing to get ready for it. But that's it. You're going to hear more from Luis later tonight, who's again one of our engineers here. Ed Iskendarian's here with us in the house. Ed's one of the founding fathers of SEMA, and so we're let's get on with it. Let me introduce Matt Stone to you. Matt's a man of many talents, and he's a journalist, broadcaster, editor-in-chief at Motor Trend at one time, written thousands and thousands of articles, 15 books. I think the latest is Ed Iskendarian's book. And he's the guy I'm going to pay off at the Pebble Beach Concourse because he's one of the class judges. And so, Matt, we'll talk later. I've got a car coming up that I want to bring to Pebble. So, anyway, Matt, why don't you join us in Iskendarian?
Ready? We're going.
Take the other one, Ed, so I can talk into your microphone.
Thank you, Mike, for that introduction. Ed, here's your water. And we very much appreciate the folks at SAE inviting us and SEMA for hosting us. Welcome to a little storytelling with the Grandfather. Just to set the scene, Ed, what day were you born?
1921.
What year? July 10th? 1921.
Yeah.
Before you reach for your calculator to do the math, that makes Ed 98 years old. If there's anybody that deserves one of those shirts that says "Still plays with cars," it would be Ed. Now, Ed is with the name Iskenderian. You might guess him to be of Turkish-Armenian descent. Although he was born in Tulare County, makes him a born American dude. And Ed, when did you move to Los Angeles?
When did I meet?
When did you move to Los Angeles?
Oh, 22, because my dad got frosted out on the farm. Wouldn't be a crop, he wouldn't be able to make the payment next year on the farm. Had a down payment, you know, depending on the crop to make the next payment. A grape farm, you know.
And running around Los Angeles, you saw these wonderful cut-down little noisy cars. What did you think of them?
Yeah, that we were riding bicycles, and that was
Can you hear him on his mic?
That was the most fun riding and fixing our bicycles. I think I've got my own, see if I missed
They're
my,
not hearing you as well.
oh, is that right?
We'll just do
So, I thought there were only two in the world, and they were in our neighborhood. And one was a little junkie, and the other one was pretty nice. The kid had money, I think, that guy. So, I said, wow, that looks like where the fun is. And we found out we could go over to where he lived, and he'll show us the car and tell us about the place called New Rock Dry Lake, where you can see a lot of them. Several times a year they have big straightaway runs up there for top time. Run over a garden hose, and that would set your time. Then it doesn't take long. So we're learning off the older guys because there was nothing to read at the time. So and it was lucky, two guys in the Bung Hoover Club were in my neighborhood, and I could go over there and watch them work on their car, and learn off of them.
A little side note about that, which I always found interesting.
Learn-
There was a bunch of their group that used to hang out at one of their guys' shop. His father was an electrician. And the father didn't think these kids playing with their cars and all that was worth their time. So he used to come around and talk to the kids, and he called them a bunch of assholes. And they wanted to form a club, A-holes, but they didn't think the A-holers was a good name for a car club. So it became the Bungholers. I'm not sure that's better, but that's what happened. Ed, tell us if anybody in here remembers, and I know Gail will, and probably a whole lot of others, back when there were building banger motors for Model Ts and Model As, you used to see heads and carburetors and exhausts and cams and all kinds of stuff that said Winfield on. Who, to you, was Ed Winfield?
Oh, yeah. It didn't take long to find out. The most knowledgeable person in racing engines and camshafts was Edward Ronald Winfield in Glendale, California, born in La Cañada nearby. And one fella got to visit over there and come back and with the word volumetric efficiency. Oh, that sounds good. What does that mean? Well, filling the cylinder all the way up would be 100%. Easy to do at low speeds, but hard to do at higher speeds. Wow. Well, it finally came a day when I had a job that could make a little money, and I could afford to buy a $20 cam, because I picked up a set of V8 heads. They were F heads, half overhead and half flat head, for the early V8 Ford. Well, he come and he saw that I brought him in. They were low compression, and I somehow knew, and I guess right, high compression, it gives you more power, so I made them as high a compression as I could by taking it to Arco Welding downtown. They heated them up and filled in the combustion chamber, and now I had to grind it out. And as I'm grinding it out, I have only one intake valve in the head and one in the exhaust. I'm starting to, hey, there's a breathing passage here. How big should I make that? So I'll ask Winfield when I buy the cam, for the cam. He says that needs to be 9/10 of a square inch. I said, gee, I wonder how he knows that. So I made it that big or a little bigger. And most guys could not get past the front door at Winfield's, especially if you're what we call a squirrel that don't want to know anything about engines. All you want to do is beat somebody by putting a cam in their car. So he let me in, and he let me see the cam grinding attachment he had made on this cylindrical grinder. Wow, I was fascinated. I had a job in a machine shop. I was kind of an apprentice. I said, gee, I could even make one of those cam grinding attachments. You don't have to buy the whole machine with the grinding spindle and all that. You can buy that already made and put your cam grinding attachment on there. So after the war, we all learned a lot more, all us GIs, by observing government, working on government equipment, and we discovered those GMC superchargers and all that kind of stuff. Everyone come back, figuring they're going to go faster at the dry lakes now, and so forth. So everyone learned a lot more working on government equipment, mechanically.
Now, a lot of people have said that Ed could grind a camshaft out of a broomstick. And I believe that. Now, Ed, when I look at a camshaft, I understand it, of course, but how did you figure out the math of that thing? These two lobes go this way and these go that way, and they all better be spinning and bumping at the right time, or you got a problem. How did you learn the mathematics of of all those load timings and
Well,
all that stuff?
it so happened that these engines were flatheads with a very simple valve train, no push rods and no rocker arms. So there was no, so you could beat up the valve train, and everybody else was conservative. Now I made the machine, I had to try it out. I have to make a master and try out the machine. So I laid one out with no clearance ramps. I read in the book about the clearance ramp. For 30 degrees, you only lift a half a thousandth for every degree of rotation of the cam, and gradually take up the clearance so there won't be any noise when it opens the valve. Well, I'm leaving that off. That's gonna take a little, I'll have to buy a rotary table and this and that. So, so I made just a base circle, a flank with about a 6-inch radius, and a little radius on the nose, and another flank for the closing ring. Almost slapping the valve open. And that's what it was.
You old valve slapper, you.
We actually slapped it open, and it was noisy. I sold the first one to a kid down the street, because speed shops were reluctant to buy it from me. You don't know nothing, you're just a kid that races at the dry lakes. So, this kid didn't ask any questions, and when he got in his 32 Roadster, I could hear it coming half a block away, the tapping noise. And I was ashamed of that. But luckily, Hot Rod magazine had come out, and I put a $10 ad in there, 2 inches, $5 an inch. And they, back there, they were green too in NASCAR. They're running flathead Fords on half and 5/8 dirt tracks. Ford and Chevrolet weren't big sponsors in those days yet. And they heard that about speed equipment being made in California. And even the cam helps. Buy a cam. So they called up, S&S called up, and they wanted to buy 2 cams by air mail. I said, wow, these guys are great to do business with. And I was afraid he was going to ask me how much experience I had. You have a few months experience. He didn't ask. And he didn't ask any specs. He just wanted to buy a cam, anything. He heard that makes the car go faster. And by God, they bought them by air mail, and then they start buying it again and again, and I didn't know why. Now, when I thought, well, in this cam grinding, I figured if I fool around enough, I'll stumble onto something. And you know, the first thing I stumbled on was that first cam. And I didn't even know what it was good for, but I finally found out, out on the racetrack, with this cam, you could pass all the other cars and work your way to the front, because it had more mid-range power. It only had the rev to 5,500 with power, and it'll go way up past that, but with a loss of power, but it'll rev. Well, I finally found out what was good about that cam. And it's the first one I ever made. Now I have time to learn about more technical things that are coming out with those push rods and rocker arms. Well, so fast action is good if you keep away from valve flow, and short timing helps low end power and mid-range power. And for the very top end, you can run soft action, but you'll only have long duration, of course. You only have your power at the very high RPM. All right. So, let's see. You ask a question.
Okay, I have one. In the earliest days of Iskendarian racing cams, some speed shops would stock your parts. Some speed shops would not. How did you get at a grassroots level? How did you establish that dealer network, and who were some of your early dealers? And how did they sell your parts?
I right. By the way, am I talking close enough to this microphone?
Yes.
Okay, right here? Closer? Right there. Okay. Well, Carl Orr had a speed shop in Culver City. He would buy my cam because I bought a few parts from him. And he liked to experiment for Pierre Bertrand in the old days, who's and that's where Clay Smith learned about cams by working for Pierre Bertrand. And then also, Louis Center and Jack Anders got together and started a speed shop. And they were sort of a rough and tumble place. And the cam grinding, that didn't baffle them. They didn't think it was that big a deal, and they would buy cams. And one day, a guy was making a cracker box. Jack Andrews was running this cracker box boat with my cam they bought. Maybe I gave it to him. And they want to go out and break this cracker box record about 50 miles an hour, flat bottom with a flathead 4 V8. And there's no flywheel hardly, and no drive shaft. And Jack Andrews, who's got experience from the old Model T days, is revving it up and down. He says, "Boy, this thing's good. This thing's good." I said, "Jack, how can you tell? It's got no flywheel, hardly anything. How can you tell? You know, it takes the throttle real good. Not because it didn't have long timing, but fast action." And by God, he was right. And that guy set a record. And later he cracked it up. Hit a log out there and it sunk it. And he had no more money left. He brought the motor to me and I said, "I'll see if I can fix it for you." Well, all the valve seats shrunk for some reason. And I had to make new valve seats and press them in. And in the bottom of the pan, I found a big pair of carpet shears, scissors, big ones. The kids that worked there built the engine, assembled it and they hadn't heard anything. I took them back to Louis and said, "Look what your kids left at the bottom of the pan." And anyway, that engine ran okay after that.
The real story I wanted you to relate, Ed, is sometimes somebody would call you and say, "You don't have a dealer in my area."
Oh yeah.
What did they become?
Oh yeah. Now, when I put that little 2-inch ad in Hot Rod magazine, I began to get inquiries, and they'd write about what they wanted to build, and usually California guys, and I had to write them back. Now, all established cam grinders had no time to answer questions, so I hired a kid who could typewrite, and I'd talk and answer the letters. And then I'd tell the kid how to build his engine a little bit, and since there's no dealer in your area, we're going to give you the discount, $20 to grind your cams. And they usually accept that. And then I asked them if they want to be a dealer. And McDonald one time said, you list me as a dealer in Lompoc, California. My speed shop is under the bed where I keep all my parts. People come here that you put me in your ad, they think it's a speed shop. And later when he goes to a real speed shop, they tell him, "We can give you so much off on Harmon and Collins." And he says, "I can give you 25 on Iskey." "How did you get that?" "Well, you didn't want it, so a kid took it from his house, made a speed shop from his house. So I would take anything I could get." And I put him in the ad, and they were getting free advertising too.
Ed, as a frame of reference, when you started your company in the late 1940s, what did you charge for a flathead cam? What did that cost?
$20. It could be 18 or $20. Yeah. Winfield's price was $20. And Winfield later in life told me, "If you would have come to me and told me you wanted to grind cams, I would have helped you." And he would have. He did help others like Oh, shucks. That midget racing guy.
Mr. Gaston?
Two racing brothers. And yeah, I'll think of it later. So what are we talking about now? Well, anyway, the overhead valves came out. Oh boy. 1949, Oldsmobile and Cadillac came with their overhead valve engines. In later years, I talked to Winfield about this. He says, "That's my engine." "What do you mean, Ed, that's your engine?" He says, "Well, it's copied from the engine I made for Twin Coach Bus Company." What's his name, that fella's name? And he had built a special engine, made drawings of a special engine, which became, when that engine came out, it was a 6-cylinder overhead cam with bathtub chamber and squish. I think it was the first time squish. And,
Talking about Sparks. Sparks?
no, not Sparks, but, no, think of it. Anyway, squish. Do you know, and by the way, do you know that in the old days the high-class cars were flatheads or side valve engines? And very few were, like Buick and Chevrolet, might have been Chevy. What was the reason for that? Because of the turbulence, flathead drawing the mixture into the cylinder, then throwing it back into that chamber on the side and causing a lot of turbulence, the spark spread rapidly throughout the charge, and you could run higher compression with those flathead engines than you could with the side valve engine. And of course, later on, squish came on the overhead valve engines too. And so Winfield claimed that the Olsen and the Kettering engines, they call it. Old man Kettering, he says, copied my engine I made for a Twin Coach Bus Company. So, but Ed, those valves were straight up and down, and yours were on an angle. And he said, yeah, but that was done for a different reason. He claimed, and I think he meant to make a smaller V8 package, so that those valves were straight up and down, it would be a very wide V engine. Anyway, so now to make Oldsmobile had a lot of torque. They would rev the 4200 and the hydraulic lifters would pump up. So the guy found out that we could make them mechanical by eliminating the hydraulic part, make it mechanical and give it some clearance, and then get 5,500, maybe 6,000. Well, yeah, so hydraulics are no good. All the cam grinders knew that, no good, and I went along with it too. No good. They won't rev up and all that, so they pump up and all that. But that was for a certain reason. The action was too fast. No one knew what to copy. They should have been copied Winfield's overhead valve profiles, which he already had. You know, the cockpit called me one day. I liked him because he had built his own cam grinder like I did, and Engel did. Those are the guys I like. The guys that didn't like me, you had to build it yourself. He says, I don't grind cams for Chevrolet. I said, why not? Small block Chevy. He said, how are you going to beat a Duntop for $18? Oh, I see what you mean. Yeah, we can beat it, but it's going to cost $250 for a hard face cam and double springs and all kinds of stuff. But I don't darn those. And it really came out as the 3030, and they start giving it the Duntop name because Duntop was in charge of performance there. Okay, and one day in talking with Vin Gillian in later years, he said Chevrolet was afraid in NASCAR. Chevrolet is afraid Ford's gonna catch him cheating in NASCAR. Doing what? Using my cam. What cam? Hey, you don't mean the 3030, the Dundalk? Yeah, that's the one. They liked that cam I made for them, and they put it in production and made them by the thousands, so it would be illegal for NASCAR, because you couldn't run California special cams. It had to be a part that anybody could buy in a Chevrolet factory. So that was a Chevrolet, that was done. And what do you think it was originally made for? You had the master made for an old four-cylinder Chevrolet. Giovanni and somebody used to run at Bonneville, or Dilates. Anyway, all right.
And as long as we're name dropping here, in the beginning you did not have your own dyno.
No.
So you used to borrow the dyno down the street. Whose shop was down the street, and who let you run on his dyno?
Edelbrock, I happened to rent a place across the street from Edelbrock.
That would be Edelbrock
And
Senior.
so I was in touch with things that were going on there. And one day the most famous builder of famous racing mechanic was Fritz Red Boy. Red Boat? Boyd. And Vic says, Red Boat was here yesterday. I told him you were right across the street. He said the door was locked. Oh, the salesmen were bothering me that day, and I was working by myself. And I locked the front door, and I missed my chance of meeting that famous guy. So I never did get to meet him. So, Edelbrock let us run in his dyno once in a while. And later, sometimes the government has dynos for sale. You bid on them. And he bid on one and got it, a big one, and he let us have the old dyno for $1,500. Boy, were we tickled. But before we could hardly set it up, Ted Kessler in Buffalo, New York, heard about it, and he wanted it because it was Edelbrock's. And I said, okay, I might sell it to you for the same price I paid, because there's an auction at Hal Scott Motors in Oakland, California. 20 dynamometers are on the list, and they're gonna shut down that big machining plant of motors, all kinds of motors for trucks and boats during the war and before the war. And we go up there, we buy two for $700 a piece. We set up one, put the other one in the backyard, and we let Ted Kessler have it for $1,500. And Vic would like to have that back because he wanted to start a museum with that old dyno in there. We never could find it though. Oh, all right. Now we're dynoing every day. There used to be a speed shop in Long Beach called Reese and Mallard and Reese. And now they're separate. And Mallard says, hey, I'll come and run that dyno for you. Oh, that'll be good if you come on over. We'll get it set up. And he gets it going. And right on it says 4,500 max RPM. Well, he takes it to 5 when he's careful sometimes. But one of our good customers, named Bones Below, who works at the aircraft factory as a machinist and races at Lions Drag Strip with a Chevrolet, comes to the front office to check on things. By golly, it sounds like the drag strip because the motor's running in the back. And he goes around to the back and hollers. He waits until it shuts off. Joe Mallard shuts it off. Hey, does that man get paid for doing that? Hell, I would do that free. I said, man, come on in here. I like your attitude. You're going to be the dyno man. That man is leaving us. He's going to go work for IBM as a teacher of some kind. So you work under him for a while. So he is working under him for a while, and one day, Mallard is gone now, and he's got quite a bit of, what do we do here? I said, you do any damn thing you want. We're trying to transfer power. So all of a sudden, we hear the motor's going about 7,000. We're afraid of that. We run back there. What are you doing? He said, well, hell, we at the drag strip, we take them up past 7,000. So I took it up. I said, gee, that dyno must be rated at half of what it'll really take. Maybe it'll take 9,000. It's rated at 4,500. So he says, I think it'll even take more. And he takes it to 7,500. I was scared, but I got it was okay.
Ed, we are running out of time, I'm sorry to say, but I'd like to visit one other topic. Considering where we are, as you may know, Ed is the founding president of SEMA. In what year was your first year as SEMA president?
Gee, I thought
63, 4, 6, 5?
I forgot now the name.
Early 60s.
Yeah.
Okay, and
59 maybe, but I'm not
how
sure.
did you become president of SEMA?
I started to take 4-page ads in a hot rod magazine, $3,000 a month, and I was tickled to death. One day I'm across from Engelbrock, and a guy knocks on the door and he wants to do advertising for me. I said, well, look at this. I got a bunch of crap here, but you can't. The first SEMA show is in 3 days, 59. You can't throw this crap. I got a graph here and some drawings my friend made, and I think we might be able to do it. And he knows who will work overtime. He got that brochure out. I had the best piece of literature in the can business overnight, and that was by Leon Cook, my advertising man.
That was 1950, by the way.
Tell them where was the first SEMA show?
Tell us where and how about the first SEMA show?
Oh yeah, in the armory at Exposition Park, they took all the trucks out of the National Guard, and they put a speed shop in there. Speed shops. Barsky hired Peterson and Lindsay to go find the good cars to put in the show, good-looking cars, and speed shops and manufacturers let them buy booths. And race drivers like Rex Mays and Mel Hansen come through because they used to be hot rodders too. And they were amazed at what the hot rod guys had put together there. So later on, Barsky hears that these two guys thinking about starting a hot rod magazine. So jokingly, he calls in, boys, you work for me. I heard we have a magazine. And he really didn't want to put any money in it. That was a risky thing. So they started it, and that got it going. And it was dynamite. It went great. Wow.
And how many SEMA shows is coming up? What year is this coming up? Number 63 coming up. Wow.
Now, then I started taking those ads, and I would ballyhoo. Now, there's a lot of guys that really know their stuff, and they're real modest, and they don't let anybody know. They don't let anybody know how smart they are and how good they are. But I always did. I exaggerated too. Anyway, and so that's why I had those full-page ads in the magazine and Hot Rod, and I try to have a little education in there too, because some of the guys want to learn. And the other thing was, what was I going to say?
I don't know.
Then anyway, one day, so that's why I looked big in the business at the time with those full-page ads, because the wheel business had not started yet, and that was the big ticket item. And they swamped the whole thing with their wheels, the aluminum wheels and stuff. But
Well, Ed, they tell us our time is up, so we will hang around for a little while and hear the rest of the program. And we have our book for sale downstairs if anybody is interested. This was a year of my life sitting next to this guy telling stories to put into that book, and I tell you, it was one of the best years of my career ever.
I got one important thing. Mr. Blackwell over there at the toy company who got us together for that SEMA thing says, are you guys organized, you manufacturers? What do you mean organized? Well, us toy manufacturers are manufacturers. We're organized. We even have our own lawyer. And they tried to take the glue out of the kids, and the kids were sniffing or something, and they couldn't make it. So if you've got a lawyer back there in Washington, D.C., that's a big help. So you guys ought to be organized, and they started that SEMA.
And SEMA was born.
And they thought, they made me president when I wasn't there one day. And,
Please give it up for the one and only Iskendarian.
that is what will happen. Sometimes oh, by the way, some of your customers are pretty good too.
We could keep you
They
till Thanksgiving
advertising, like
if you want.
Scotty Penn says, why don't you build a 5-cycle cam for a 4-cycle engine? I said, ha ha ha. Hey, wait a minute. That would be a good publicity stunt. And it worked. And one day he said, why don't you, here's the 2 lobes, why don't you put an extra little lobe? Crazy guy. Hey, maybe I will try putting a little lobe there. And we tried to patent it, and the patent attorney made me run it on the dyno. He says, with it, without the bump on a hydraulic bump like Chevy, mile can, I can't tell any difference. You got 1 or 2 horsepower plus or minus, because the dyno's not that sensitive. So I don't think you got anything. Well, I thought if I made it run, you would patent it for me. No, you can't. So I said, all right, I'll make it public domain. Put it in an ad and sold a few. 20 years later, Fueling calls up. That's his real name. And he's an experimental guy. And a good talker. He even got money out of the factory guys with his ideas. Did you get any of your money? No. And he calls up one day and said he wants me to make this pulse cam for him. I called it a 3D cam. He called it a pulse cam. I says, hey, I've made these before. In fact, I tried to patent it and I couldn't get a patent. Well, I got the patent. You do? How did you get it? Well, I'll tell you, if you got the patent, I'll make it for you free in case we ever get this working. And he says, no, oh, Iskey, you don't understand. All the cam grinders are going to have to pay me royalties on this. Royalties. I said, I think I got you shut down. I made it public domain. And I didn't know it, but in his patent, he mentioned me. Iskey played with this and couldn't make it work, he said. But I made it work, he says. Later on, I go to Engel, good friend, making cans and mailed his old machine. He said, I'm making those pulse cams for fueling, you know. Oh, you are? Hey, let's face it, they don't work, right? He says, yeah, he does admit it's cosmetic. Cosmetic? Hell, that's the word for it. Cosmetic is what it is. And you can sell stuff if it's cosmetic, even if it don't work. So he didn't want to come to me anymore. He goes to Engel because he can be an inventor over there. Yeah. Okay. Thank you very much. I enjoyed that.
Thank you very much to Ed and Matt for that. That was an awesome interview. I learned a lot. Hope all of you guys did as well and had a good laugh out of it. Well, as everybody knows, as time progresses, vehicle technology progresses, vehicles get smarter, vehicles get more complex as well. So with that being said, I'd like to introduce SEMA VP of Vehicle Technology, John Waraniak.
Guys, made it. Guys, made it.
Is this one on? That working? Nope. Thank you. That better? No,
Work fine for
Is that on now? What an honor, huh? My gosh. Just, a living legend. Most of them are not living, particularly with the SEMA stories there. And then what I want to do is kind of connect the past, our great heritage of SEMA, with where we're going as well. There's so much happening.
How much is?
How many folks can relate to some
worth?
of the
About
names that
$500?
Iskendarian brought up? Zora Arquiston. I had a chance when I was at GM Racing to work with Zora. He liked me because I was small and I could go in the cars and he'd test me out. And then once I got one of his clay Corvettes and I pulled the steering wheel off, he said, "You don't come back. You don't come back." Yeah, I always had a cigarette hanging out of his.
Right away?
But, a lot of great names there. I want to kind of connect some of the things that we're doing here. Kind of I think it was Dean, you came up with that, the engineering story. There's a lot there, and I'll give you a little history of that as well. How many folks know that car out in the upper left? Anybody know who that is? That's the Porsche 919 Spider, won Le Mans 3 times. Literally goes two-wheel drive, 500 horsepower, so it's a four-wheel drive, about 1,000 horsepower with a flick of the switch. So that's why they won Le Mans 3 times. They didn't go back to Le Mans. They're putting their money into a lot of the electric races, particularly Formula E, as well as Audi. So you see a lot of that happen. The car in the middle is the Robocar, morphing into the Chevy Cruze. There's so much happening. This is, to me, the most exciting time to be in the auto industry. What Iske was part of and that whole hot rod movement that came out of the 40s and 50s, it's the same thing for what I'll call the digital hot rodder today. Some really cool stuff happening. I call it basically faster, smarter, and cooler, because that's what kids want. A lot of you here, that age. That's what's so cool to them. Not to just have the fastest car, but to be the coolest and the smartest car. Wasn't enough back in Iske's day to be the fastest. And you heard a lot of the calibrations he gave. You had to be the coolest, as well as the fastest, whether you're the guy or. And again, some of the things that I'm doing, I get to live in Detroit, God's country. Still is the epicenter of automotive engineering in the world. There are 85,000 engineers within 50 miles of Detroit City. It is still the epicenter. How many folks here are automotive engineers versus aerospace? Automotive first. Any aircraft? Wow, interesting. Give a little history of that too. I get a chance to work with SE International in Detroit as well as Pittsburgh. And fortunate, 20 years we've coined the term, the brand Connect to Car, which is going on its 21st year. That actually was my friend Chris Cook and myself did that, and we loaned the brand to SAE. So they take that brand, and that is the flagship for a lot of the sessions and seminars you see going on, particularly today. 21 years ago, there was no connected car. It was pretty catchy, they kept it, and they've been using it. So, a couple things, I need the zapper. And can we turn those bank lights off because they'll fade a bit. And, I'll give you kind of a snapshot here. Whoop. Five big megatrends, and I'm going to go through this pretty fast, like a drinking from a fire hose, if you will, the analogy. The big five megatrends: urbanization, climate change, economic shifting, demographics certainly shifting. A lot of reports you see out there says kids are just not interested in cars anymore. Well, go to the SEMA.org website. You'll see some very different research that said kids do like cars, they just like them in different ways. There's a lot of that happening, and certainly the technology breakthroughs. I'm going to focus on that. Look at some of those companies: Techstars, Baidu, which is the Chinese Google, if you will. Hackride. Anybody here Hackride? Automotive, the digital platform. Those are the digital hot rods. How many folks are gamers here? NVIDIA. What NVIDIA did outside the car for the gaming industry, brought that to automotive. 10 years ago, NVIDIA had no automotive sales. Today they're over $1 billion. It's not a CPU in the car, it's a GPU. So they're mapping everything literally for level 2 and 3 autonomy through NVIDIA. Now they're bringing that inside the car to map you internally, et cetera. Won't get into some of that, but inside and outside the car, everything is going to be very digital, very graphics oriented. Car on the left, 67 commercial. Car on the right, 2017 commercial. What's the biggest difference between those two cars? 100 million lines of software code. There is 0 on the left. And about 100 on the 2017. A lot more today than 19. Big difference there. As Corky Coker, and he and I presented this a couple years ago down in Atlanta, how many millennials would take the 17 versus the 67? Almost all of them took the 17. He says, well, you can have my 67 Camaro when you pry it from my cold, dead hands. I mean, that's how much passion there is behind both those cars. But I think the 67 was the start of it. I grew up in Detroit, what's known as Corktown. Anybody familiar with Detroit? That's where I grew up, very fortunate, right by the train station there. That's what the train station looked like when I grew up. Pretty much like that. Ford bought it. Ford is creating some pretty cool stuff with the train station. They're going to have 5,000 automated vehicle engineers, electrification engineers there within 3.5 years. They got about 1,000 down there now, what they call the factory, which is a building that Robbie Buell bought just a few blocks from there. My first race was a soapbox derby car, 67. That was my first sponsor, Jefferson Chevrolet. Built it at Boys Club down there, and I would say that I was a Hot Wheels generation. 67, that's what got me started. I didn't want anything to do other than race. So I raced motorcycles, didn't do very well, got hurt, ended up in a body cast for 18 months. And fortunately, I was able to skip 2 grades, 3rd grade and 5th grade, so I graduated from high school when I was 15. Had a lot of time to think when I had this plaster all over me for 18 months. And I said, I'm getting out of Detroit, I want to go, I want to fly. I want to be in the aerospace industry. So I moved, got a chance to go to graduate school at the University of Illinois, and my thesis was fatigue and fracture mechanics. And my thesis advisor, PhD thesis, gave it to the NSA. And they were building the B-2 bomber at the time. And if you come out of LAX, there's a Hilton there right on Century Boulevard. That's where we designed the B-2. Flash forward, they sent 15 of us to Caltech as part of the stealth program because Northrop didn't just bet the pig, they bet the entire farm. They had to win the B-2. There would be no Northrop Grumman, and a lot of things. So big crossover there. Flash forward, General Motors wanted to buy Boeing at the time, mid-80s. Boeing said absolutely not, so GM kept pressing. Roger Smith was the CEO at the time, so they ended up buying Hughes Aircraft right here in Fullerton, and also Gunville, from Hughes Medical. Being that I was on the stealth and we were part of Boeing and Vought and Hughes, I got a chance to take 100 systems engineers and program managers from Hughes to General Motors. Great opportunity to transfer technology into automotive from aerospace. First thing we did was the crash boxes on cars, took that off an F-16, put that right onto the race cars. We ended up winning the Triple Crown, we wrote a book on that. All sorts of cool things happened because we transferred that aerospace technology into automotive. That is where we're at today. It's very much a system of systems. Flash forward, when did we stop going faster at the Indy 500? A long time, 93. So it's not about just going fast anymore. There's a lot more happening. As I mentioned, great book on the Mustang. If you haven't read it, Faster Horse. Well, it's not just about that anymore. It's fast and smart, which is part of that cool factor. If you look at that top shelf there of parts, those are all the things Iskenderian worked on, right? And some of you here, right? There's Gail. That is the shelf, a lot of the things that we talked about over the last hour. Look at that bottom shelf. Velodyne LiDARs, NVIDIA GPUs that are mentioned. All sorts of things on there. Mobileye cameras. Those are offerings to the god of, I'll call autonomy. And there's a company in Morton, Illinois. Bobby Hambrick started this. Autonomous stuff. Pretty clever name, right? Just like Cam Father with Iskendarian. He is that shelf. Just about every automated vehicle being built in the United States here today, and some in Europe, comes from that shelf. Whether they're an OEM, whether they're a supplier. And one of the coolest things they do up at Thunder Hill Raceway, outside of San Francisco, first Saturday every month, they race autonomous vehicles. And about 45 companies show up every Saturday. Mostly garage, I'll call them SEMA type companies. Kyle Vogt got his start there from Cruise. George Holtz with Comma.ai. Actually, George still has the track record up there. Google's there, Apple's there, Waymo's there, Baidu is there. Pretty cool place. If you get up there on a Saturday of the month, you'll see some of the coolest racing around. Again, it's not taking the driver out of the seat of racing. That is the driver, I'll call it the technical deployment. It truly is the technology that enables us to get to some of these levels of automation from a safety perspective, particularly software perspective. In interest of time, I'm not going to go through the video there. We're getting late. We had a chance, how many folks are familiar with the American Center for Mobility? Proving ground in Detroit area, Ypsilanti. We had a chance to take the robocar there when it was racing at the New York City Grand Prix, and we took it to M-City as well, which is University of Michigan. It's a fake town for autonomous vehicle testing and all these technologies. And they've got the autonomous bus that takes you around the track. It's a fake railroad crossing, and a little everything there to confuse the vehicles, to put them in real time. Because every one of us in this room, you will not own an autonomous vehicle. They will not be ready for prime time for at least 20, 25 years. You may see fleets that have them, but from a liability perspective, look what's happened with Tesla, autopilot, things like that. In Detroit, there's 5,000 autonomous vehicles running around. Go to any of the OEMs, automakers, you can drive from one building to another in autonomous vehicles. But you can't take them out of those with geo-fenced areas because they're not ready for prime time. You'll see a lot of the testing, again, but they have to be there. The automakers have to have 1 foot today and 1 foot tomorrow. They want to be seen as technology companies. They have to do that to surface. And if you go just flashback 2008 when it was almost dead, big changes in the industry took place then. Literally, GM, one of GM's strategies today is to have, in 5 years, about 40% of their workforce under 30 years old. So that tribal knowledge goes right out the door. And most of those folks are not what I'll call automotive engineers. They're software and electronics engineers, electrification engineers. Very low. I mean, they probably wouldn't know who Iskenderian is, most of them. Or SEMA. They think SEMA makes trailers after a hurricane. FEMA. A lot of the stuff we're seeing, the technology in the cars, literally came right out of aircraft industry. LiDARs, radars, cameras. They help the vehicle see, think, and act. Huge opportunities there. Everybody in this room, particularly SEMA. If you look at a SEMA report on ADAS, it is about $1 billion aftermarket industry, just for the SEMA side, aftermarket ADAS. I mentioned the levels of autonomy, and this again is directly from SAE, adopted by NHTSA. We're right in the middle. Level 1 and 2, we're going to be there a long time. The biggest jump from 2 to 3 is the transition back to us as a driver. Just about everyone that's been killed in an automated vehicle so far, it's that transition. They either didn't wake up, didn't know it, or couldn't react in time. And computers are great at analyzing, terrible at driving. A lot of humans are pretty good at driving, terrible at analyzing situations or the behavior side. So we need both. We're a long ways from that. I'll give you some estimates of the time it's going to take. What's happening is a lot of the OEMs are branding safety performance. Safety performance is a whole new area for SEMA in the aftermarket. Safety performance. Ford calls it Copilot 360. Toyota calls it Toyota Safety Sense. Nissan's got its version. They all have different versions. They all want basically a suite of these things. Automatic emergency braking, lane departure warning, blind spot warning, all that kind of stuff. But it's not just about the new cars. When Neil Young was at the SEMA show, he made a great statement. He said, an old car can take you to new places. He built a 59 Lincoln, turned it into a hot rod hybrid, equivalent about 800 horsepower. It's got 50,000 miles on that thing. Drives it all over between Canada. Shows it to folks in DC, and just repowering the American dream. And a lot of kids get excited about that stuff and want to be part of it. So it's great to have a spokesperson like me over there. I mentioned the report, SEMA.org. Get this. Goes through all those 9 buckets of technology. It's pretty deep, but it really did highlight the opportunities, the business opportunities for aftermarket ADAS. When I talk about aftermarket systems like that, it's all the passive stuff. Warnings, lane departure warning, blind spot warning, forward collision warning. It doesn't take control of the car. It just gives you that warning, mostly a light or a sound or something like that. It doesn't take a great driver like all you hear to make you better. It takes that shitty driver. Makes a heck of a lot. And that's the person that's going to get you when you're leaving here at 57 or 60, right? So you want them to have that. These are the buckets, the areas. A lot of stuff going on there with Robo Race. Obviously, Hot Wheels is getting into that next generation. For me, it was 67 to have that the mongoose car and snake car. Now Hot Wheels is coming out with the iHot Wheel, so you can race against somebody in Japan, someone in China, someone in California, someone in Michigan. So it's almost like Strava. If you're a mountain bike rider or some other, we compare your performance. You have to compare your Hot Wheel performance of your race on their orange track to someone else's. Pretty cool stuff happening. These are all the little areas I think that are popping up. This area here, that's a sweet spot. You'll see 50 companies at the SEMA show, just in those spots alone, working on those technologies. Gives you an idea of the growth. As I mentioned, about $1 billion industry over the next at least 2 more years. Real data. IIHS is a nonprofit organization that is out there to drive what's happening with these systems. And reduction of deaths, 40%. This stuff works. That's why all the automakers are doing it. And they are so far in front of consumers, they're so far in front of suppliers, they're so far in front of us. Someone's got to fill that gap. The aftermarket has to help fill that. Where's the folks from Hanson? ETF Labs. I was at their lab today. They see it. Chuck Hanson, visionary. He says, we got to fill this gap. And that's his analogy. Great way to do it. They're doing it right down here in Anaheim. You have to calibrate the sensors. I mean, you take a vehicle apart. I mean, there's literally, as I said, 100 million lines of code on that car. Probably at least 50 ECUs, electronic control units. Maybe 12, 15 computers on that car. And the sensors, cameras, ultrasonic, radars. Some of them are going to have lidars as well through the windshields, all sorts of things. So when you're modifying that car as a SEMA member, you got to know what you're doing to those systems. Just a lot of primer on the bumper will make the sensors inoperable. You put a wrap over the bumper or the tailgate. Ford likes to put a lot of the sensors in the rear tail lights and headlights in their housings. You change out the headlight assembly, taillight assembly, the systems don't work. Again, consumer can say, okay, I agree, I don't want those systems to work, and sign off on that. But again, you're paying for those systems, they expect those to work even after you've modified the vehicle. It's not just about the safety factor, it's the congestion too. When one of those cars crashes, this is Ventura Freeway, it hasn't changed much in 50 years that I'm aware of. Same amount of cars. It took me 2.5 hours to get up here from Huntington Beach, another ADAS lab I was at this afternoon, just to get back here in time for this. Since we've been talking, actually about 45 minutes, 525 people in the U.S. alone have been hurt, seriously. 4.6 of our friends and those people have died. 92% of those could have been prevented with ADAS technology. 60% today are caused by human behavior, misjudgment. Didn't know the car was going that fast, didn't see it in the road, maybe. So this stuff works. There's an aftermarket group called Vision Zero that has the goal of saving 10,000 lives just through aftermarket technology alone. This is right outside of Mountain View. I remember being there. That was one of the first Teslas that crashed. The guy was sleeping. It's going to take so much testing to get this done. They say 8.8 billion miles of testing to get to level 4 autonomy. That's why I say it's so far out. That's the equivalent of 520 years of testing. It ain't going to happen. It has to be simulation. So that's where the gaming industry comes in the gaming engine. Things like Forza, Car Sim, kids that grew up with the gaming engines, Automotive, Unity, Unreal, that is what's driving and making automotive cool again for that 8 to 14-year-old kid today. And those are the ones that GM wants to hire, Ford, Toyota. There aren't enough of them in the world. They all want it. And it's not getting any easier. A lot of the automakers tell their dealers, you cannot modify the vehicle because it's too complex. There's an article I wrote 6 years ago that said, does SEMA have 5 years left? I got more hate mail in that article. I said, well, did you read the article? They said, no, I just saw the headline, I had to call you, John. I took that article headline from 1971. Because back then, people like, it was even Iskendarian, electronic fuel injection came out, they thought that was the end of the aftermarket. Well, it isn't, because SEMA, like Jurassic Park, finds a way to get it done. We'll find a way to help get through a lot of this. And it isn't just the safety, it's something called cybersecurity. That is getting really tough, where they want to lock the vehicle down because it is very hackable. All this data coming off a vehicle goes through the cloud, those are all hackable surfaces, as they call them. So great opportunities to get in and help prevent things from being hacked, but you got to be able to modify the vehicle as well. I was talking earlier about some of the new players in the technology. How many folks familiar with Rivian? Pretty cool. Performance electric vehicles, a truck and an SUV, got a massive amount of money. Amazon gave them $750 million, Ford gave them $500 million. 2 weeks ago, Cox gave them $500 million. They're moving that forward. They'll have those vehicles for sale next year. I think eCoco introduced that at the SEMA show last year. First electric Camaro, fastest Camaro they've ever built, all electric. That is what part of the industry is going to. The good thing about all of us here, we get to do both. Internal gas combustion engine is going to be around for another 20 years. And they keep making more and more and more improvements to it. There's an Ed Iskendarian, next generation Ed, out there working on that right now. But you will not see new engines in that. You'll see variations of the old, better and better and better, until it reaches a point where these just have to take over. I'll call them muscle electrics and hot rod hybrids. But make no mistake, the cars are works of art, access, power, fashion, and fun. Certainly mobility is a big part of that, but so is your phone, so is your computer. There's that cool factor too, that'll always be there. So what would Henry do? Or Steve Jobs in that case today? They would rethink the entire thing, and that's where Hackard comes in. Mouse McCoy, 3D prints, hot rods at Oak Ridge Laboratory in aluminum. It's a government facility. He started building some of the hot rods, but the government has taken over almost all of his capacity to 3D print anything with the Rangers and the Delta Force and the Seals. So a lot of cool stuff, and he's right up in Ventura. So somebody may want to keep on your radar. I'm not going to get into the details of this. Pretty cool stuff. We're benchmarking a lot of this. We have a lot of associations that we work with, particularly collision repair, and that's kind of what Hanson grew out of. And if you get a chance, if you really want to know more about ADAS and the opportunities and challenges, I'd say contact the folks here from Hanson. I'd glad to show you what they're doing, particularly if you're a SEMA member and working with it. I call this collaboration. I helped start a company called No Fear down in Carlsbad, and that was one of the shirts I did that said, you can't just be involved with the collaboration. You've got to be committed. And the analogy was a breakfast of ham and eggs. The pig is committed, the chicken's involved. You've got to be real about collaboration. And that's where the automakers are. They are the pig. When it comes to a lot of this new stuff, they have to be committed to it. Otherwise, Wall Street will shut them out. Shut them down. And you see that happening every day. SEMA show, we went through the history. SEMA to me is the intersection of cars and car culture. That's why it has such a long life. Car culture, lifestyle keeps changing, so does SEMA. CES is the intersection of cars and technology. The Detroit show, which is being moved to June, was the first to reinvent itself. It's the intersection of cars and consumers. And SAE has a big presence at the Detroit Auto Show. We need the culture, we need the technology, we need the consumers to come together. And if you're not familiar with the Detroit show, it's 3 shows in one. Media days with the media. Dean was there all the time. There's industry days. 40,000 engineers will come to Detroit in January because they can scan the vehicles, they can measure them, they have access to all those vehicles on the show floor. Only show in the world that does it. And then they have consumer days. Now that it's moving to June next year, I'll bet 50, 60,000 engineers show up to that. I would imagine SE International will take a big chunk and hopefully move some of the World Congress stuff to the Detroit Auto Show. Because that's where the action is. The schools involved, they have a day, total day just dedicated to schools. High school, K through 12, and then college. Something to take advantage of. So what are the takeaways? I'm not gonna go through all that. I can get this if you like. But certainly the gamification of engineering is huge. That is one of the biggest driving factors for what I'll call Automotive 4.0. The digital tools are saving time. We did this with Ford a couple weeks ago. They have 100 3D printers just in their advanced manufacturing facility alone. The 3D print production parts for the Raptor, for the Ford GT, for the Chevy Mustang, for the Escape, right there in Redford, Michigan. So this is not kind of like the plastic parts you think of as building a prototype. These are production parts that they're building for around the world, for all different markets as well. Startups are colliding with the traditional players. Future factories are really driving that too, because it's not enough just to have the physical test. You gotta have what they call a digital twin. If you do the physical test, it might cost you hundreds of thousands of dollars to do that crash test or that ADAS verification and compliance test, but you need to simulate that back to the 8 billion miles that have to get done. Someone's gonna find a way and make a lot of money. There's gonna be a lot of Iskenderians out there over this next wave of safety performance. And the hot rod movement was the first movement. I'm calling this the digital hot rod movement because a lot of people will take advantage of it. Lastly, I didn't bring it, how many folks remember when Elon Musk launched that on the Falcon Heavy last February, right? I think it's right around the sun now, right? He put that Tesla on board there. I did get one of these though. This is the car that they have on the IP. Amazon said it was the last one, but I don't believe that. They probably say it's the last one every day. But that is truly the inspiration. To me, all the places I go to, particularly the K through 12 with World in Motion with SE International, kids get excited about that kind of stuff. They really do. These are the kids you're going to be hiring or competing with, some of you younger folks here, that are doing a lot of this. And it truly is. I mean, if you missed the first hot rod movement, what I call an era and an attitude, don't miss this one. This is fun times. It's got Detroit on fire. If you haven't been to Detroit lately, Detroit is basically 40% are under 24 years old. I don't like it because they've driven up all the housing prices and everything else. And the bars, they take over, but they are ruling the epicenter of engineering in a very good way, changing quickly. Luis, any questions, any comments? We promised to get you out of here by 8. Any questions, or Luis, you want to wrap in, or Dean? Please.
What do you see as far as the Southern California car culture? How is that evolving?
The trends still start out here, absolutely, because of the car culture, absolutely. And I think with, you saw that one photo I had of the Ventura Freeway? You want to drive your hobby car, you don't want to sit on the freeway. So there's going to be a ways that you'll have a commuter, could be semi-autonomous, level 2, ADAS equipped, but you can have a fun car too. And I think that's where the industry is going. The cool thing is, it can be internal gas combustion engine, it could be a hybrid, it could be a pure electric. That's where Southern California is the market for all of them. I would bet Rivian, 40% of its sales the first year or two will be here, Southern California. And they won't be like the Tesla expensive. It'll be 70 grand, but it's more of a, I'm going to call it an adventure vehicle, not a Tesla experimental.
Starting with what I call the easy stuff of a sensor telling you that you've come within 10 feet of a vehicle and you hear the beep, beep, beep. That and what's coming quickly down the pike, do you have any guess whatsoever what percentage of crashes is this eliminating? Per 100 crashes, how many less? And maybe even deaths. You got any idea?
40%.
Immediate, I mean, right now, just the
Right
beep, beep, beep thing,
right now.
we've decreased crashes by 40%
Yes.
just because of the 20-foot beeper.
Yes.
Well, but it's
John?
more than just me.
It's It's the bumper, it's the passive and active coming together. 40,000 people have been killed in the United States for, pretty much that's the ballpark. That's equivalent to 2 737s crashing and falling out of the sky and killing every passenger every week. No one would put up with that shit. Yet we accept it. 2 people get killed in an autonomous vehicle, it makes the news.
Hey, John, just repeat the question when you give the answer so the video can pick it up.
Oh, gotcha, okay, yeah, we'll do it, yeah. Please.
How do you see the deployment of the autonomy as we reach level 4, how do you see it being deployed in metropolitan areas? It's likely going to be deployed there first and then branch out from there.
It'll be in geo-fenced areas where they can control, where only autonomous vehicles will be in that space.
Okay.
You will not have manually driven vehicles in this. Question was, how do we see level 4 autonomy being deployed? It's not gonna, you'll have to keep them separate, driverless vehicles and driver vehicles. There'll be a point where you're, right, even today with Progressive and others, if you have systems on board your vehicle and you opt in to share that data with the carrier, they'll decrease your premium. If they see you're driving very quickly and stopping fast, accelerating fast, you may drive up your premium. So be careful. When you let Flo sell you that little OBD2 connector, you'll be on that commercial with her. Cool. Please, again.
How long until you believe a car will be able to sense a pothole or a speed bump? You're going too fast, slow down for the speed bump or the pothole. Or is that we're gonna wait until the car's talking to each other?
Good question. How long will it take before a car can like sense a pothole or an obstruction? It's already here. It doesn't slow the car down, by the way. Ford has it. You can go to YouTube, you'll see it. Just look up Ford and potholes. Microseconds, nano microseconds, whatever that number is, the wheel stays up and goes over the pothole. It doesn't go down. The suspension holds it up while it goes over that pothole.
Is that in production cars
Yes.
now?
And it's pretty simple. No. Yeah. Yeah, if all 4 come up, you're going up. Yeah. Absolutely, yeah.
So what about the back? I mean, wouldn't the back be let in? Back?
Yeah, I think the system is on board, but it's smart enough to sense it. Obviously, right front needs it first, you see it, sense it first. Yeah, and a lot of those are optics combined with the, and guys at Hanson may know more, on the sensors that are involved with that vehicle. For each of the weirdest thing is, all the OEMs are taking their own approach to it. So it's like the wild, wild west of how they're putting the sensors and how, not necessarily in the pothole situation, but the sensor being able to react to what it sees.
When do you think we'll see that in, say, half the cars are gonna be?
Oh, gosh, long, long time, 20 years. Because people, even ADAS, the systems started, it takes 5 years to get to like 5% deployment rate. Because there's basically 18 million vehicles sold in the United States alone. But I mentioned the 40,000 deaths in the US, 1.2 million worldwide.
The reason I ask is because some of this is a real bike accidents, we just don't want anyone to die.
Yeah, fixing wheels, yeah, absolutely. That's always gonna keep happening. Matter of fact, the cost for insurance premiums are actually going up, even though the collisions are going down. But because you have these systems on board and the cost to repair them, they're collecting money now because of the big payouts. A camera, $1,500 bucks. Some of the ultrasonic sensors, $2,000 bucks. So you go in for a small fender bender, and you've wrecked this equipment, you're talking a $3,000 bill just to replace the sensors.
I'll chime in on one thing, actually, even like just the emblems themselves are special actually too, so if we came across one that was, just the, replace the emblem, it was $400 just right.
That's a good point. A lot of these sensors are behind the brand emblem, like the Toyota cowboy hat or the Chevrolet bow tie. They're right behind that emblem on the grill. So when a SEMA member takes that grill off and puts a billet aluminum grill or something over that, you got to recalibrate, relocate that sensor, and make sure those systems are compliant with the way they start. Please.
Hi, I'm one of those kids that hopefully you guys will hire someday. I'm a mechanical engineer at SEMA UCI.
Good question. If I had to paraphrase, I'd say what's a mechanical engineer versus electronics, software? You're becoming a rarity, which is gonna go full circle and make you even much more of a valuable engineer, because a lot of them are steep in the software and in the, not electric, but electrification. There's a big difference between electric vehicles and electrification. Drive-by-wire, steer-by-wire, all the systems. They still have to come together as a system of systems. That's where the mechanical engineer comes in. It's gotta be packaged. I didn't go into detail on design versus branding. The design is the content. The mechanical engineering is the context, how it all comes together. It's a car, it's an aircraft. All the systems are packaged into that mechanical thing that flies or drives. And if you don't believe that, just look at the race car teams. There's usually a mechanical engineer at the head of it, not an electronics.
So, I work in the ambulance manufacturing industry, and one of the questions I always have is, how can we improve safety for our emergency responders? Well, a lot of the systems in the back of the truck are not developed by the OEMs, but we're looking at, all the impacts that we're having, lights and sirens is no longer a sufficient announcement method. A lot of these cars are very well isolated from road noise. All the different systems inside the car are very distracting, so they don't see the flash ambulance lights in the background. And we have a lot more injuries and accidents every year, it seems to be. Is there any of the systems that's being developed specifically to reduce those interactions with first responders?
Yes.
And those emergencies?
Good question. Hopefully you heard of it. What's happening with like first responders, ambulance drivers, emergency vehicles. The big thing is, and again, back to the connected car. Connected car means one connecting you as a driver, passenger to the vehicle. The other is connecting you to the other vehicles on the road. The other is connecting you to the infrastructure, they call V2X. That is the biggest, where it'll send an emergency first responder vehicle coming up to an intersection. Won't just rely on the sound or the lights. It'll send a message to that car and to your phone. And the biggest thing there is still distracted driving. Because those situations happen so quickly, they want to use the infrastructure, what they call a smart intersection. If you go to M-City and Center for Mobility, you can see that demonstrated all day long. How emergency vehicles coming up, cars aren't literally stopping or anything. It'll send that message, and in some cases, activate the ADAS system on board that vehicle. Oh, absolutely. You can change lights. And,
We have problems with change the green light and red light.
Yep.
Stop the intersection. But that doesn't stop me from driving the intersection.
Oh, absolutely. Whether it's emergency or not. Yeah, distracted driving is what's driving those numbers up over 40,000. It's amazing. And again, SAE is really, really helping lead that effort. SAE is our channel through our collaborations to NHTSA. Because the current administration is not putting out any new rules, any new regulations. They're relying on SAE to be the technical experts for this. And a lot of that information is coming from certainly racing and production. How many folks have been to the PRI show? SEMA owns that as well. That's performance and racing industry. That's in Indy in December. Chip Ganassi said it well on one of my slides. We've got to keep technology and performance at the forefront. Because racing is still the gimmick, the front line for literally demonstrating technology and solving problems on a world stage. Racing you're doing, women's racing, that is it. If you're not racing, you're not trying. If you're not trying, you're cheating. Get out there and win and demonstrate to the world what you can do with racing. And that's the stuff that sells. Please. And by the way, you can leave anytime. You can, I mean, depending on where you're driving back to, you might as well stay here till you go to work tomorrow.
So John, when are we gonna add a third dimension to our traffic patterns?
Third dimension to our, when are we going to add a third dimension to our traffic patterns? Good question. Any civil engineers here? You mean like a third deck on the 405?
No.
Oh, flying.
Yeah.
Well,
When pigs
if
fly.
you're brave enough, you can go up to Silicon Valley right now and fly one. Basically, I want to be a drone crash dummy, but you can do it. There's a lot of startups that are into that. I can't imagine the challenges there though from a legal perspective. Any lawyers here? Where's Chris? Here's Chris, he's our resident CEO and lawyer. Dean?
What do you hear on battery costs? There's two conflicting opinions right now. As we increase volume, prices will go down. The more demand for limited supply of raw materials may drive prices up. What do you hear?
I think the battery chemistry is changing all the time. They just, that's how much they can do, like the Gigafactory. What they're doing with that battery chemistry is probably still the state of the art. But I guarantee in their R&D labs, whether it's Silicon Valley or Detroit or Nagoya or Frankfurt, there are some pretty good batteries, but they can't get it out to production. Cost wise not. The cost is going to continue going down. Mary Barra, CEO of General Motors, they're convinced there'll be 5% electric vehicles by market share by 2030. It's not big, but that's a lot of batteries. One of the biggest things holding that up though, Dean, is what do you do with the battery after the vehicles? You're going to use it to power your house? What are you going to do with it? Because there's so much investment in it. If you remember in the early days of electrification of the powertrain, you would lease the battery, turn it back in, they could use it for other, like storing energy off the grid, that kind of stuff. It's all over the map. I really don't know. But that's a big challenge. I mean, like a Rivian, as I said, they'll sell mostly out here. For me to have a Rivian in Detroit, January, February, March, it'd still be parked in my garage. 30 degrees, loses 30, 40% of its power. 10-degree days, I wouldn't take it out of the garage because I wouldn't get to my meeting where I'm going to Rivian headquarters.
So John, given that, what's your view on other alternatives, what electrification means versus battery electric vehicles, fuel cell, hybrids, and everything that's
Good question. What are the alternatives? It's all over. If you look at some of the automakers, as I said, they have to have one foot today, one foot tomorrow. Toyota rules hybrids. They've got a great powertrain. They've taken the Prius. They're into like the 12th year of the Prius architecture. It's on the RAV4. So the hybrid is the bridge between internal gas combustion and pure electric. Think of the infrastructure again. If everybody jumped to the pure electric so quickly, it constipate the grid. Can't do it. So all sorts of alternatives there. But GM has shown that they can't make money with the hybrids like Toyota has. So they're getting out of that and they're putting all their bets on pure electric.
How about fuel cell?
Fuel cell, Honda pretty much runs that. I think Mirai with Toyota. Not so much in the US, but certainly Asia, where they're jumping the infrastructure. It's kind of like, to me the analogy is mobile and digital phones versus landlines. You go to India, you got better cell reception than you do here in elsewhere. Because they jumped to the infrastructure for mobile wireless technology. Whereas we still have the landlines competing, so it's a mismatch of everything, band-aids everywhere. All right. Pleasure. Thank you very much. And good luck to all your starting your careers and the rest of us are shining years. Use us as consultants.
Thank you, John.
Thank you, Louise.
On behalf of SEMA and SoCal SE, we'd like to thank you for joining us tonight. If you are a student, we'd like for you to stay behind and Dean Case has a few bits of information you'd like to share with you. If you have any questions regarding SEMA or part of the tour or anything like that, please feel free to grab me or any other staff member in the room. Other than that, have a safe trip home and have a good night.